Sample 1 tells us that we're going to exert a 36 Newton horizontal force as he pulls a 52 Newton sled across a cement sidewalk at a constant speed. What is the coefficient of kinetic friction between the sidewalk and the metal sled runners if we ignore air resistance? So in our big picture, free body diagram, right? What's going on? What forces do I have? So downward we have the force of gravity, and upwards we have force normal. Does it move up nor down? Okay. What do we have side to side? Okay. What do you want to call that 36 newtons? Okay, so we have force applied equals 36 newtons. What's this 52 then? It's the weight. So I already multiplied my mass times gravity and went ahead and told you 52 newtons is the force due to gravity, right? Or the weight. And then we have a friction. How do you want me to draw my friction? So it's opposite of FA. And we'll call this FF. Now, you told me my gravity and normal matched. How did you tell me that my gravity and normal matched? We know that the net force... Wait, does this fly off the surface? Does it sink into the ground? So what's the acceleration? So if the acceleration is 0, what does the force have to be? Okay. So the net force is 0. And also, that's in the up and down direction, right? So then the net forces in the up and down direction are what and what? Maybe I should say force normal versus force gravity. Mathematically, right? That makes more mathematical sense to me. And so if that equals... Wait, we said the net force is equal to 0, though. So I've got force normal equals force of gravity. So on the AP test, I would expect you to explain something from F equals ma. Okay, that's our starting. Also, it will simplify your problems if you're like, okay, I need to start with F equals ma, break down what that means, but also look at the diagram and build your equation from the diagram, okay? That's the two things you really need for the test. Force normal versus gravity, they're equal to each other. Alrighty, so we've got 52 newtons of gravity. So we have 52 newtons of normal force. What about friction? Let's talk about friction. We need to know what friction is. Wait. I know what friction is. Do you know what friction is? I can just look at the problem and see what friction is. The force acting against the force applied. That's a good definition. It's 36 newtons. I agree. That's why when you told me to draw it shorter, I was kind of slyly just drew it just about the same length. 36 newtons. Why? What was the big giveaway that it should match? Constant speed is code for... Yeah, it's at equilibrium or no acceleration. And so the net forces in the x direction is the force applied versus force friction. And therefore, if that equals 0, FA equals FF. So now we know that that's 36 newtons. How do I solve for mu? The coefficient of friction is what versus what? Yep. Mu equals what versus what? Flip that. Take the reciprocal of that. Wait. I'm just trying to write an equation. What did you say? Force friction divided by force normal? So it's 36 divided by 52. Newtons. And I think it already tells you what the answer is. What did you get as your answer, though? 0.69. Good. What's the units for that? I'll give you a hint. The term is coefficient. There is no unit. Newtons divided by newtons is 1. 20 divided by 20 is 1. So we're going to multiply this by 1. There's unitless. It's unitless. All right, that's sample 1. So keyword there. Also, we just kind of assumed a direction it's moving, so I'm not going to report back a direction. Also, we're just looking for the mu value. It doesn't have a direction. That's the interaction between surfaces. All right. Part and page 2. Part 1 is close to similar to the same. What's going on in this box? What do you want to tell me about this box? It has an applied force. It has a pre-drawn arrow. Can we draw anything else on it? Gravity and normal. Do you want them to, which one do you want to be longer? They're equal? I'll try to draw them equal as best as I can then. Force normal. Force gravity, force normal. What's the force of gravity? I put mg next to it. Agree, disagree? Okay. 25 times 9.8. Good. You're the ones with the calculators at your table. I have none. $245 newtons is the force of gravity, right? Okay. If it's similar to the last problem, what's the force normal? You know it's 245 newtons, but we have to prove it. So we're going to say that the F equals ma, and that A equals 0, and therefore my force equals 0. And so my net force also equals what versus what? Right. Yeah, this is just in the y direction. You're right. You're right. We're just in the y direction. And, yeah, because something's going to happen in the x direction. That's for sure. Gravity minus normal, which means I can say gravity equals normal. Right? That's what you told me. So I need a little blurb setting them equal to each other. And so if you're able to see that this line is the same as this line, you just need to practice telling me why. 100. What's holding it back? It didn't say that it's moving at the same speed, though. What are we going to do for this? Yeah, they gave us the coefficient this time. Mu times force normal equals force friction. We have the mu, and we have the normal. Oh, not too hard. I got 70 what, 0.5. $73.5 units. Newtons. Direction? Left. This one is up. That's a boxed answer. This one's a boxed answer. What else do I need to do? I need to do the second diagram too. What's the same? Tell me what's the same. The weight is the same. I'm not going to make you resolve it if I asked you for the same thing. 245 newtons. Is that it? Yeah? I think we're only using one mu and we can make the connection of what I'm using. I don't think that would be a factor on the AP test. As long as you're making the connections, I think you're okay. But if you feel safer labeling it, I would feel safer now too, now that you bring it up. I'm just kind of like, oh yeah, maybe. What else is the same? One other thing is the same. The force applied technically is the same, but in a different direction. The mu value is the same. That's it. The interaction between the boxes is the same. All right. Here's the problem, though.
The force normal will be longer than force gravity.
Right. Oh, whoa. Shorter. Whoa, where are you getting that idea from? So I'm going to draw my force normal, and that's all I'm going to draw. Why?
Because the force is acting on an angle, so we have to find the vertical component of the force.
Right. So where we're fighting this is when we set up our net force in the y direction. What makes up our net force in the y direction? What goes down? So I'm going to put force gravity versus what goes up? Force normal, and also...
Force applied, sine, theta.
Yeah, force applied in the y direction, which you might also write FA sine theta. Both mean the same thing to me at this point. Okay. Well, then that changes our math a little bit, doesn't that? The fact that I'm pulling makes this item lighter. The fact that I'm pulling it up makes this item lighter. Here, let me give you a live example. If I were to push and pull a chair while, let me pause it, but if I push and pull a chair while at an angle, if you're pushing into the ground, it gets more friction, and if you're pulling it up, it would get less. Let's see it. Alrighty, so we know that the force here at an angle will lighten up how much it pushes against the surface. So here's my equation set up. We said Fg equals, wait, does it move up and down? No. And so we can say that this is all equal to 0, right? We can say F in the y direction equals m times a, which is 0. And so what else are we going to say? Right. If I rearrange it, we can say 0 equals, so Fg, we're looking for normal force, minus Fa in the y direction equals force normal. All right. 245 minus 100 sine 30. That's 50. So 245 minus 50 is 195. So our normal force is 195. Does that change our friction? We just said so, didn't we? We saw the chair being pushed and we can feel it. More or less friction if I lighten it up. Well, why don't we just find out? Mu times force normal. 0.3 times 195. Right? Not too bad. What's my force friction? I agree. 58.5 newtons. All right. Pulleys. How does this change pulley systems? What would happen if I didn't have any friction? What used to happen? It goes down. We know it goes down because of the force gravity on 2 equals m2g, right? It would move both the masses, right? Which of these have friction now?
Box 1.
Box 1 has friction. And so we have the force of friction here. We have still FG1. Why did I need that? Because we're going to need force normal here. Tension. Is tension in or out of the system? In the system. So I'm going to draw it in different color just for clarity's sake. It's a real force, but if I look at the whole system, I don't have to be concerned about tension. This is outside the system. This is outside the system. They cancel each other out most of the time. This is outside the system. Oh, this is outside the system. So if it's not moving or if it's the same speed, they would cancel each other out. But this one's still going to fall. What do we need to know? What do we need to set? How do we set it up? This versus that. Net force equals m2g Let me just leave it as force friction right now. Okay, so we've got gravity trying to pull it forward, friction holds it backwards. That's the only two I can see outside the system in terms of the way this object or this system will move. Okay. I need a little bit of an aside right now. I need to figure out what friction is then, huh? What is friction? What's the equation for friction? Force friction.
Force normal.
Mu times force normal. So what's force normal?
5 multiplied by 9.8. Because, first we have to state that.
Right, you're telling me that force normal equals force due to gravity because what did you know? The net force in the y direction for box
Is equal to 0.
1 equals 0. You need these two on your paper. At least bare minimum these two. You probably should actually say the step in between, that force normal minus gravity equals 0. Or equals the net force. But this is how us physics teachers will grade your work. And how we know that you're thinking through the process and what you are thinking. Otherwise, I'm just going to assume that you just magically came to the knowledge and not give you the points that I need to give you, right? All right. Wait. That just means that that's m2g minus. You told me that this is mu times force normal. That's the net force. What else is the net force? Net force always equals MA? Okay. So if I can say that the net force equals MA, I can also say that this side is both the masses. M1 plus M2 are being moved. And that will equal M2G minus mu M1G. I have M1, I have M2, I have G, I have mu. Just plug it in to find A. Eight times 9.8 minus 0.2 times 5 times 9.8. Divided by 13. Equals A. I don't know what you get. 5.3? 5.3 what? 27? Okay. Meters per second squared. And that's down for this one and to the right for this box. They're both going to move with that acceleration. Are we done? No. We still need to find tension. How do you find tension? You look at each individual diagram, right? This one has gravity and normal. That doesn't matter too much, but we have tension and friction. Gravity and normal. This is box 1, by the way, right? If this was box 2, where would tension be? Up. T versus force of gravity. So on box 1, what's the equation? Tension minus force friction? The net force equals tension minus friction. For box 2, the net force equals force gravity minus tension. All right. Anytime you see, so for box 1 is force on net force on 1, force friction on 1. So I've got M1A equals, we know what M1A is, equals T minus M1G mu M1G. And what do we do from here? T equals MA plus BUMG. All right. That's how I would solve it for the top box. For the bottom box, we have M2A equals M2G minus T. We have T equals M2G minus M2A. And they should give you both the number 36-ish. Newtons. All right. How much time do we have? 9 minutes. Good. We're on time. Skier. These are the kind of crazy problems that if you've gotten everything that we're doing, this is really easy. And if you need to go back to slopes to review, this would be good practice for the test. Here's my skier. Lovely drawing, right? What do we know is happening? Real forces only. Gravity is a real force. What else?
Force normal.
Normal force. And force friction. Those are my 3 real forces. Okay. What are helpful to not really real forces that I could add in here? Oh, I just need one imaginary force.
Force, gravity, sine theta.
Okay. So this is force, gravity, sine theta. So if my angle is right here. And I'm going to draw this as a dashed line as well, just because it's not real. So force, gravity, sine theta. What is this upwards line that I had to draw dashed in?
This is our normal force.
Yeah, it's a redrawing of this normal force just translated over there. So what is the normal force equal?
Force, gravity, cosine theta.
Right. Mg cosine theta. This is mg sine theta, right? I could have just said force gravity, mg sine theta. All right. Wait. If I'm talking about the way it'll move, is it going to leave the ramp magically? So if I turned my paper this way, my ups and downs all cancel out, and I only have to worry about the side to sides. What is side to side? My net force equals Fg sine theta. Wait, we said to rewrite that as what? Mg sine theta. And, okay, which is mu, yeah, mu Fn. There's my mu Fn. Right? You told me Fn equals mg cosine theta, so that's my force normal right there. Wait, what's that force equal? Okay. What cancels out then? So that's why I didn't even need to tell you how heavy the skier was. To find the acceleration, it is unrelated to the mass. This could be a child skier at like 20 kilograms, 200 kilograms. This person could be 2,000 kilograms. I would have said, ooh, at 200 kilograms. That's still like 440 pounds, man. All right. But you have you don't have the mass, but to find the acceleration, all you need is g sine, 20 degrees? Then they give us the mu value at 0.1. G cosine 20 degrees. All right, that's it. That's it for today.